Section 8.4 is going to talk about similar triangles specifically. So we already know what similarity means, so refresh that.
Okay, so for figures to be similar, they have to have congruent angles, corresponding congruent angles,
Good.
and their corresponding sides are proportional.
Okay. So we are going to apply this idea of similar figures to triangles because we know triangles are kind of unique. There's a lot of kind of interesting, cool things about it.
We love triangles in this class.
And you kind of explored, we had to kind of explore that today, just like a little quick example just to kind of get you thinking. So today we're going to actually apply that, or tonight we're going to apply that.
Okay.
It says, in the diagram, triangle LMN is similar to triangle PQN. So they're telling you they're similar.
Right.
Which essentially means what Ms. Hokery said, all the corresponding angles are congruent and all the corresponding sides are proportional.
Okay.
And this name, is that important for us to make sense of?
Right. The order is important.
Okay. So the first thing I want you to do is, for you guys to do, is write the statement of proportionality. Okay. So this is just a review from yesterday. So you might just go ahead and do that and then check with us. Okay. So let's go ahead and
write our proportionality. Okay. So I'm looking really not at the picture. I'm looking at the similarity statement. And I know that segment LM corresponds to segment PQ.
Okay, so that measure corresponds to that. So this ratio is going to equal to
MN over QN, and then LN over PN.
And again, notice how she wrote this. She started with the first triangle for each of them and then matched it up with its corresponding part. These could be reciprocal of all of these. But remember, statement of proportionality is basically saying all the ratios for those two similar triangles are equal. So you're going to have those. And so this time, since it's triangles, you have three ratios that are equal. All right, so then let's move on. And part B says find angle M and find angle P. All right.
Well, as I look at the original similarity statement, I know that angle M should correspond with angle Q.
Okay.
And I know angle Q is 36, so I know angle M is also going to be 36.
So these are exactly the same. So angle M's measure is 36. And I might just label that up here because who knows, you might need it.
Right.
All right, what about angle P?
Okay, so looking back at my similarity statement, angle P and angle L were corresponding with each other, so those should be congruent, but I notice I don't have a P or an L.
Okay.
So then I'm going to go back to my picture, and I'm going to notice that the angle MNL is 106. So I could talk about how to find the measure of angle L, or I could even say its vertical angle is also 106 to help me find P. Either way you want to do it. But I know that if I take my really the 180 degrees of the triangle and I subtract the 106 and the 36, I'm left with a 38.
So that's which angle?
That's angle P, measure of angle P.
And you could technically say angle L, but they didn't say find angle L, but we technically did, so we've answered that. Good, so a little bit from even last semester, the triangle sum theorem. All right, let's move on. It says find the measure of segment MN and the measurement of QM.
Okay, so as I look at MN in my similarity statement, MN corresponded with QN, and QN we actually have was 20.
And so, you can even, you said similarity statement, you could even look at your proportionality statement.
Absolutely. Good. So MN and QN. So I'm going to write that ratio.
So MN to QN, that's your...
And I'm just going to write MN over 20.
Okay.
Okay, and then now I need two things that I do have. And as I look at, and I'm just going to look at my proportionality statement. I like that idea. Looking at LM and PQ, I do have those.
Yes.
So I'm going to go ahead and use that ratio. And that one was 33 to 30.
Now notice, and essentially, that's why the statement of proportionality theorem, or statement of proportionality is convenient, is you're not going to use this whole entire statement. You're going to use two of the ratios. And the two that she chose were these two, because we know LM, we know PQ, we know QN. So our unknown, which is they're asking us to find MN, we can use a proportion that way. Okay. So we're essentially using that part of the statement there. Okay, and notice again how she set it up. Make sure things are corresponding, matches up. All right.
All right.
So you go and cross multiply.
So 30 mn is going to equal, let's see, that'll be
660.
Yep, 660. Divide by 30. So mn is 22.
And keep in mind, guys, you could have said, if you were like, oh, I want to use X,
just label it.
Label it. But notice you have another piece that you're missing. So you don't want to label that X as well. All right. I love that Ms. Hochraby had me just use MN. Because then we know this is the segment we're finding, and we can be good with the answer if this is the final outcome.
Okay.
All right. So let's move on. QM.
All right. So QM, that's the whole segment.
This whole entire thing.
Which we just found MN, and let's label that as 22. And using the segment addition postulate, I can just add those two pieces together, the 20 and the 22. So it's going to be 42.
So that was just more just a, again, refresher from last semester.
From early last semester, too.
All right. Now, keep in mind, we're focusing on now similar triangles. That's going to be our focus.
Okay.
Well, maybe.
We have a postulate for you. We haven't seen a postulate for a while. And it is the angle-angle similarity postulate. And we kind of looked at it a little bit in class today, too, where we found that you don't really need all three angles, because once we know two angles, we already know the third angles are going to be congruent too. So if two angles of one triangle are congruent to two angles of another triangle, then those two triangles are similar. I want you to notice, what do I not have listed here?
I don't have to know anything about the sides.
You know nothing about the sides. So all you need to prove two triangles similar is two sets of corresponding angles congruent.
And that's what kind of you explored today. That's what you guys saw here. And that's what's nice about this postulate. This kind of really is a shortcut. I mean, a huge shortcut.
Huge shortcut. So, and we will use angle-angle similarity, or AA similarity. It's just our name for this postulate.
And make sure you have that similar sign. Don't just put AA. Notice it's not called AAA similarity, because you don't need that third angle like Mrs. Hochraby said. Okay, so if you know two angles, of one triangle congruent to the other, then those triangles are similar. So you would say this triangle is similar to that triangle.
And we can write all that out, but I know since we explored that today, I think you guys are.
And we're going to actually do a lot of that in just a moment. All right, so several of the examples today, it's just deciding if the triangles in the picture are similar or not.
Okay.
And then if they are, you're going to write a similarity statement, and if they're not, you're going to explain.
Okay.
These are really popular type questions for even a quiz or test, so just be kind of ready for that.
Fantastic.
It says, determine whether the triangles are similar. So let's decide. Hopefully you see two triangles in that picture.
I do, and I see two right triangles.
Okay. So right away, if they're right triangles, we already know what?
We have one set of angles that are congruent.
So these angles right here that are right angles are going to be congruent to each other. If it helps, notice how one triangle is inside the other. If it helps to kind of separate them out, kind of to see the two, okay, that might be a good option. Not saying you have to, but it can always help.
It's a good strategy.
Especially when we proved triangles are congruent, anytime triangles overlapped, we often drew them separate. So we know these two angles here are congruent to each other. Okay, so we already have one set of congruent angles.
And obviously, because we just learned a postulate, I'm kind of looking to see if there is another set of angles that are congruent.
Okay, so what are you thinking?
I do see that they have that overlapping angle, angle W.
So that would be congruent
to
itself, which means...
And that's kind of using that reflexive property idea. And so therefore, I've got two sets of angles that are congruent. Therefore, these two triangles are similar.
So it says, if they are similar, write the similarity statement.
Okay, so let's do that. I'm going to call the first triangle, the smaller one, triangle WVX. And I'm going to say it's similar to triangle WZY.
And when you write your similarity statement, does it matter?
Yes, the order does matter.
So however you name the first one, that's one you can kind of write however you want. We'll determine how you write the next one. And again, make sure you put the similarity symbol, not congruent symbol, because we often, we've dealt with congruent mostly this year. All right. So just kind of keep that in mind. And it doesn't say anything about anything more. It doesn't say give a reason. It just write the similarity statement. So that's really all you have to do on this problem.
Awesome. Okay, for this next example, same directions. Determine if the triangles can be proven similar. If so, again, we're going to write the similarity statement, and if not, we're going to explain. All right, take a look and see what you think.
Okay, so I'm noticing the two triangles have, because we're thinking angles, because that's the only reason, unless we use the definition, and the definition's way too long to prove.
Right, that would be all sides proportional and all angles.
Corresponding angles congruent. Okay, so I'm just going to focus on the angles. And I notice in each of the triangles, they only give you one angle, and neither one are congruent. So does that automatically mean they're not similar?
No, not necessarily.
Because maybe they're not the corresponding angles. Keep that in mind. All right, so the second thing I'm noticing is that the two triangles, both of them are isosceles.
Now, because they're both isosceles, does that mean that they definitely are similar?
Not necessarily.
Right.
Just because we have to make sure the corresponding angles are congruent.
Exactly.
Okay? So what I do know, isosceles triangles do tell us something about the angles.
Yes.
When you have two sides are congruent in a triangle, the base angles are congruent. So angle N is congruent to angle O. So that means those are both 71.
Okay.
Okay. I could find angle M. Since I know two angles, I could find angle M. And angle M, I think, ends up being 38.
So you really took probably 180 minus 71 minus 71.
Exactly.
That would give you 38. Okay.
Now I'm going to my other triangle, and you may not need that. We'll just see. I just found things I can find. So the next one, same idea. Since that's your base angles are congruent, so angle P and angle R are congruent to each other. And if they give you the vertex angle, which is 38, I can subtract that from 180 and divide that by 2. And that gives you 71 in the end.
Okay.
So each of those are 71 degrees.
Love it.
So essentially that means the triangles are similar, right?
Yeah, and really, we did more than angle similarity here. And that's okay to do more work than needed. But you don't need all three sets of angles, but you kind of needed to be able to get to the other parts.
So essentially, if you're proving if they're similar or not, you need, especially right now, you need to show me that either there's two pairs of congruent angles or that they're not. You need to make sure you find those angles.
Okay, so it says if they are similar, we're going to write that similarity statement.
So, okay, so I'm going to say, let's call the first one triangle MNO is similar to triangle. Now, I got to start with angle Q because M and Q are the same. But I also noticed that P and R are the same as N and O, so I could do QPR or QRP, either way, right?
Either way, exactly. Now, again, here they didn't say to explain. If they did say why,
I would just say angle similarity.
Angle similarity. They didn't ask for that, but you might see some of those in the future, so we'll go ahead and just make sure we know.
All right, so same directions. All right, take a look. We have two triangles.
Okay.
And talk to me about what you're seeing.
Well, I see a perpendicular mark. I see that there's two segments that are forming a right angle.
Which means if this is a right angle,
then the other side, because it's a linear pair, is also going to be a right angle.
Okay.
And I also see two other angles that are marked, and they're not the same, but they may not be the pieces that correspond.
Exactly.
But I do know if each triangle, using that triangle sum theorem, has to equal 180, I could find angle C and angle A. Okay? And when we do that, we'd find angle C is 52 and angle A is 28.
And the other thing to keep in mind with a right triangle,
those two equal 90.
Will add up to 90. So you could just do 90 minus 62 and congruent angles. But do we have another?
No.
No.
So
what does that mean then?
That means that these triangles are not similar.
So not similar. And it does say explained.
So I could say that I do not have two angles that are congruent.
So
so there are not two sets. Don't have
two pairs of corresponding congruent angles. Okay, now you can't say I don't have congruent angles. Well, because we do.
Right.
You just don't have two pairs. All right. So, or you could say not all the corresponding angles are congruent.
True.
Okay, so just how you word it, guys, when you explain it, you got to make sure you support it. All right, some of us are not always that great about doing that. You got to be very clear and exact in what you're trying to say.
And we want to definitely mention something about the angles since that's what we're
So notice, just real quick, notice the 3 problems we've done so far. We found, well, 3. This first one we did. But these last 2, if they ever give you a measure in the triangle of an angle, probably need to find some other angles.
Right.
So just keep that in mind. Okay, so this would be kind of supporting. This would be work to support why you did this. Okay?
Exactly. All right. This is just something that we want to, it's good for you guys to have down. It says if 2 polygons are similar, so when you've got polygons in general that are similar, the ratio, we talked about a little bit of this, but the ratio of any 2 corresponding lengths,
So like side lengths.
so side lengths, which that's what we focused on.
Uh-huh.
We've talked about perimeters.
Okay.
But they're also saying things like altitudes and medians and angle bisector segments and diagonals will be equal to the scale factor of those similar polygons. So what I want you guys to realize is that anytime you have any similar figures, all of the linear lengths, the straight length, things that you could measure with a
Segments.
ruler, segments, all segments within there that correspond will be that same as the scale factor.
Okay.
Okay?
That makes sense.
So just, we've talked about the scale factor is the same as, that scale factor ratio is going to be the same as the perimeter ratio, which is the same as the side length ratio, corresponding side length ratio. But again, it's also the same as, and we could list them all, I'm not going to list them, but the altitude ratio, the median ratio, the angle bisector segment ratio, the diagonal ratio, all of these just special segments that we have within there are also going to be in that same ratio.
And notice the things that she kind of circled here. Those are all within the polygons.
Right.
Whereas side ratios are the what makes up the polygon. Perimeter makes up the polygon. So that's why this is kind of add-on, because now you can apply it to things that are inside of the polygon.
Exactly.
Okay? So let's keep that in mind and take a look at this particular problem.
Okay.
It says find EH. So we're finding the length of EH given all of this stuff.
Okay, so let's mark our picture.
Now, one thing to keep in mind is in this picture, I'm hoping you see, what kind of polygons do you see?
Well, I see some triangles.
Okay, so that's probably what we're going to be focusing on.
A lot of triangles.
And what do you think's going to be true about the triangles?
Well, I'm hoping that they're going to be similar.
Okay, so let's think about that. Keep that in mind. I'm going to start labeling. All right, it says...
In fact, while you're labeling, I'm just going to... They are definitely similar because when I look at that, angle C and angle E are already marked in the picture as congruent. And the two, if I look at triangle EAB and CAD, those two triangles share angle A.
Okay.
So that's another angle that's congruent.
So
these are similar
what the
triangles.
two triangles she's talking about, just to kind of highlight that.
Yes.
It's this one right here and then the bigger one. Because you said that there's several triangles in here, and there are, right? So she's talking about the overlapping triangles. And reason why is kind of what gives it away. They gave you these angles here are congruent. And they do share that common angle down here, angle A. So angle similarity postulate proves that those triangles are similar. So we have similar triangles, which essentially means all its corresponding sides are proportional, corresponding angles are congruent. Now even the last slide, any corresponding length is also the same ratio.
Which I think is going to be helpful here because I know you've marked CF as 6, and we're finding EH. Those are both altitudes. They go from that vertex, and they're perpendicular to the base. So I know that those altitudes are even proportional as well.
And if you think about it, again, it's going to be their corresponding sides, which is what their scale factor is going to be the same as that ratio of those altitudes. So essentially, we need to find a corresponding side ratio in a sense.
Okay.
Do you see one that we could do?
I do. They don't really give us the whole side of one of the triangles, but what you've marked at the bottom, that AD
Let me draw those two
Yeah, I
triangles
think that's going to really help.
while she's kind of talking here.
But that AD, that bottom segment, the base of the triangle, and I know that would be the base because they've given us the height marked. That base of 5 corresponds to the base of AB, which they don't technically give us all of AB together yet, but we could use segment addition postulate to get that that's going to be a 12.5.
And then, so those are your corresponding sides. So if I compare AD to AB,
that's our corresponding side ratio.
So then I would say that's equal to
the altitude ratio. So,
and the altitudes, here's 1, this is 6.
And then that one's what we're finding.
And this is our unknown. So we would say 6 to
EH.
EH. And I like that you left it as EH. Now again, if you want to say X, make sure that you're in this one. It wouldn't be a big deal because that's the only thing you're finding.
Right.
All right, so you go ahead and cross multiply. So you're going to have 5 EH equals, what, 75?
Yep.
So EH ends up being
15.
And we should expect an altitude larger than the other triangle, right? And notice even comparing, if I compare that altitude to the base, this altitude's larger than that. This altitude should be larger than that base. Okay, so kind of a couple different comparisons there.
All right. Guess what, guys? You've missed them so much that we decided we should definitely make sure to bring back a proof this chapter.
Yay!
We'll see some, and don't panic when you see them.
There, you can handle it.
You can definitely handle it. They are giving us here, we've got triangles, which makes sense because this section is about proving triangles similar. And they tell us that segment DE is a mid-segment. Ooh, this is a vocabulary word. Oops. That we haven't seen for a while.
Okay. Since chapter 5, I believe, is when we saw it last. So that was back in like November.
Yes, it was, of triangle ABC. And so we're going to talk about that in just a second. That is all we're given. And we are supposed to prove that these two triangles, and hopefully we see them, they're kind of overlapping a little bit, but triangle ABC and triangle DBE, we're proving that those two triangles are similar.
So
okay?
I'm thinking really the best way to do this is to prove if I can get two pairs of congruent angles.
Right, because that's obviously the postulate we focused on today was the angle-angle similarity. Okay, now let's talk for a minute. What do you remember about this vocabulary word? Because we know when we've got a vocabulary word in our given, we want to define it.
Okay.
What is a mid-segment?
Well, the definition of a mid-segment is a segment that basically is formed by the midpoints.
Mm-hmm. Just gonna.
Now, that doesn't really necessarily help us with angles.
It doesn't.
So the definition here isn't going to really help us here. So I'm thinking there was a theorem.
There was a theorem.
And the theorem stated a couple things. It said something about the fact that the midsegment was half the length of the opposite side. So DE would be half of AC.
Uh-huh.
But that still doesn't help us with angles.
Right.
All right. The other part of that theorem said that the midsegment was parallel to that.
Right.
Okay. So that means I could say that DE and AC were parallel. Now, I'm thinking that's probably what I want to say.
Because we know that when we've got parallel lines, there's lots of special angle pairs
Exactly.
that we can be looking at.
So let's say in step 2, segment DE, which is your midsegment there, is parallel to segment AC. And the reason for that is the midsegment theorem. That's just the name.
Perfect.
So again, this is one where the definition didn't necessarily help us, but it kind of gave us kind of a dialogue of where we were going with it.
Right.
Okay.
And we're still going to have to do something when you've got a statement. You're not going to just use
so you
statements.
think about, okay, either what does the definition tell us anything? Okay, if not, is there a theorem that tells us something?
Right.
Theorems are very helpful too.
Absolutely. Okay. So now that we know that we've got a set of parallels, what else do we know?
All right, well, I'm looking at that picture, and I see that both of those segments intersect two different transversals, both of those sides. So that essentially means that I'm going to have a couple different things I could say. I could say, with that transversal there, that angle BDE is congruent to angle A, and I'm just going to call it angle A. And that's because of corresponding angles postulate, because they're corresponding angles. So those are congruent. Now, there's another transversal, the segment BC. And when I do that, I have another pair of corresponding angles congruent. So I'm going to put it in the same step.
Sounds good.
So angle BED is congruent to angle C for the same reason.
Perfect. Now, there's actually another set of angles you could have talked about here.
Yeah. And why don't you label that angle C is congruent to angle?
Sorry.
That's okay.
Started it.
But technically, you could be done here. But if you notice, angle B is congruent to itself because of reflexive or because of third angles theorem. Either way. But I like this because then I can just go to the proof.
Yeah, I just want you guys to realize that you could have done any combination of the two angles on this one.
As long as you get two pairs of congruent angles, you're good to go.
That's right.
So let's end the proof. See, that wasn't bad.
Nope, two sets of congruent angles, so we know that.
Triangle ABC is similar to triangle DBE, and that's because of angle-angle similarity.